Hi, I'm Jared Van Landingham, and today I'm going to talk a little bit about convection, and I'm going to do a little demonstration to explain this concept. First of all, convection is the energy transfer between a solid surface and the adjacent liquid or gas that is in motion. In motion here is the important part, because conduction is the same thing but without motion. There are two types of convection. There's forced convection, which is where the fluid is forced to flow over the surface that is conducting heat or energy. And then there's natural or free convection, and that's where the fluid motion is a result of the buoyancy forces, which are induced by density differences, which is a result of the temperature difference in the fluid. Convection is heat transfer, and it's normally found using Newton's law of cooling. Q is the energy transfer rate of convection. H is the convection heat transfer coefficient. Now, H is dependent on a lot of things, such as surface geometry, the nature of the fluid motion, the properties of the liquid or gas, and the fluid velocity. AS is the surface area of the that the fluid is passing over. TS is the temperature of the surface, and T infinity is the temperature of the fluid at a distance away from the surface. Now I'm going to do a little demonstration where I will change the type of convection. I will compare natural or free convection to forced convection. I'll do this by taking two identical amounts of ice and putting them in the same amount of water, and in one of the bowls I will stir it and the other I won't. And so the bowl that I stir will be forced convection, and the bowl that I don't stir will be natural or free convection. Alright, now here I have two bowls, each filled with the same amount of ice, precisely measured from a used medicine bottle, and they both have very similar surface geometries because they're frozen in the same bowl. They're at the same temperature. And the only differences between these two will be the fluid velocity in the one that I stir and the nature of the fluid motion, because one will be forced convection and one will be natural or free convection. Now, this water is obviously from tap water, so it has the same properties and it's at the exact same temperature. And so as I pour it in here, both start to melt at about the same speed. I'm going to start my stopwatch. And I'm going to start to stir one of them. Now this will cause the fluid velocity, to increase, while this bowl only has natural convection to aid in the heat transfer. And so as this bowl, which has a larger H value, and I showed you in that equation earlier, if H increases, so does Q. And so as H increases so by a lot more in this one, Q will increase, and so the ice will melt faster because there will be more energy leaving the water and going into the ice, which turns the ice into water. Alright, as you can see, the ice is completely melted, and in this bowl, which was forced convection, while in this bowl the ice is maybe melted halfway or 3/4 of the way, but still there's a lot of it there. And as you can tell, there's a huge difference between the two types of convection.